In the last lecture, we studied about the linear inequation and how to formulate the LPP problem of one question for the maximize and the second question for the minimize. Now we go further. The question number 3 in the same exercise 6.1. Question is, a company manufacture two type of a chemical A and B. Each chemical require two type of raw material that are P and Q. The table below shows the number of unit of P and Q required to manufacturing 1 unit of A and the 1 unit of B. Chemical and the raw material is given. Chemical A and chemical B is given. Availability is given. Raw material P, Q given. Now, in this question, they given the company gets the profit. So, very important point is profit of rupees 350 and rupees 400 by selling 1 unit of A and 1 unit of B respectively. Formulate the problem LPP to maximize the profit. So, objective function is given for the maximize the profit. And the profit function for 350 rupees and 400 rupees. That means each chemical A with the A unit, 1 unit of A chemical, we got the profit 350. Then X unit of a chemical A, we got the profit as a 350X. Similarly, 400 profit on the unit, 1 unit of a chemical B. That's why Y unit of a chemical B, we got the 400Y profit. Okay. So, in this question, we have to first decide the decision variable X and Y. So, we consider let X unit of chemical A and Y unit of chemical B is produce. Okay. If we decide the decision variable, after that we have to find out the objective function, and objective function we see the maximize terms. So that's why we write profit is equal to 350X and 400Y. We already see. Now, from given condition, that means this condition is given. With the help of this condition, we write the constraint part. So, number of A chemical we write as a X and number of Y we write as a chemical B. So, for the P purpose, we write 3 into X plus 2 into Y, and availability means maximum number is given. Whenever the maximum number is given, we use less than or equal to symbol for max. Okay. And greater than equal to for minimum. So, from the given condition, we write here 3x plus 2y less than equal to 120. This is used for P material. And for Q material, we write 2x plus 5y less than equal to 160. Now, given X unit and Y unit of chemical A and B respectively, therefore X is greater than equal to 0 and Y is greater than equal to 0 are the restriction symbol. So, given formulate LPP is as follows. We write first part is our objective function, second part is our constraint, and the third part is our restrictions. Maximize Z 350x 400y subject to 3x plus 2y less than equal to 120, 2x plus 5y less than equal to 160, and the restriction symbol x is greater than equal to 0 and y is greater than equal to 0. Here we complete the question number 3. Now we see the next question, question number 4. A printing company prints two types of magazine A and B. A company earn rupees 10 and rupees 15. Now company on magazine A and B per copy. On the one copy they earn 10 rupees and the same for the magazine B, each unit they earn 15 rupees. This is nothing but the profit function. Now the second, these are produced on the three machine 1, 2, 3. Magazine A require 2 hours on the machine 1, 5 hours on machine 2, 2 hours on machine 3. So they are given the information. So they are given the information regarding the magazine A. Okay. So magazine A, for that purpose we have 2 hours machine 1, 5 hours machine 2, 2 hours for machine 3. Second, magazine B required 3 hours for machine 1, 2 hours for machine 2, 6 hours on machine 3. Machine 1, 2, 3 are available. That means availability is given in the question is 36, 50 and 60 hours per week. So in this question they are given the two magazines A and magazine B. They are manufactured on the machine 1, 2, 3, but the availability for the per week is given 36, 50 and 60 hours. Availability, maximum availability is given. Okay. So we use this sum as a maximum type. So first of all, in the last sum we see the tabular formation information, but in this question we are see as a theoretical information. So first of all we convert this theoretical information in the tabular form. So we write magazine, and the second one we write as a machine. We have magazine A and magazine B, and second concept is availability. Okay. Now machine 1, machine 2, machine 3. So how to format the information in the tabular form, that we see here. So I write in the box. So it is easy to write down in the equation. So magazine A information, write down 2, second one is a 5 and third one is a 2. We already read this one and collect the important parts. So that's why it is easy to write. Magazine B 3 for machine 1, 2 for machine 2, 6 for machine 3, and availability is 36, 50, 60. Okay. Now profit is given what? 10 and 50. This is the profit function. Now most important is a decision variable. So we consider as a x unit for the magazine A and y unit for the magazine B. So we write let x be the number of unit of magazine A and y unit of magazine B. Okay. Are produced. Now profit Z is given 10 for each magazine. So number of X magazine 10X, 15 for the magazine B. So number of Y magazine 15Y. After that we write constraint. Okay. So from given condition, constraint is always written for on the basis of conditions. So 2 into X plus 3 into Y for the first machine and availability is 36. Okay. Machine 1. Now for the machine 2, 5 into X, 2 into Y, minimum 50 for the machine 2. Now third condition, 2X plus 6Y less than or equal to 60 for the machine 3. For the 3 machines we write the conditions. Now the last part is a restriction, so where X and Y are unit of magazine A and B. Therefore X is greater than equal to 0 and Y is greater than equal to 0. Formulate LPP. Whenever we write the elements in the form of LPP, that time we have to write down maximize Z is equal to 10X plus 15Y, first condition. Second, subject 2 is 2X plus 3Y less than equal to 36, 5X plus 2Y less than equal to 50, 2X plus 6Y less than equal to 60, and the important part is restrictions. X is less than or greater than equal to 0 and Y is greater than equal to 0. So in this question we see how to write the data in the form of tabular form, and tabular formation we convert in a LPP format. Question number 5. A manufacturer produces bulbs and tubes. Each of these must be produced through two machines M1 and M2. A package of bulb required 1 hour of a work machine M1, 3 hours of a work on machine M2. A package of a tube required 2 hours on a machine M1, 4 hours on a machine M2. He earned a profit of rupees 30.5 per package of a bulbs and 55 per package of a tubes. Formulate the LPP for maximize the profit. Now, in this question number 5, you see they are given the requirement of a 1 hour of a machine M1 and 3 hours of a machine M2, okay, for the bulbs. And for the tube they are also given 2 hours for M2, M1, 4 hours on the M2, and the profit function also they are given, but the one condition is not given, that is availability. Okay, so in this question they are not given availability, but in the earlier year same question availability is given. A manufacturer produce bulbs and tube, each of these must be 10 and 12 hours be produced through two machine M1 and M2 respectively. That means the availability is given 10 hours and 12 hours. Okay, so you have to just remark here the must be contained availability is 10 and 12 hours. Okay, that you have to add the data in the question. Now we see the solution. First we have to write down the decision variable. Let X be the number of package of bulbs and y be the number of package of tubes are manufactured. Now this data we write in a tabular form for bulbs, tubes and availability in hours, that is not given in a question, but we take the help of the previous syllabus, machine M1 and machine M2, 1, 3, 2, 4 and 10, 12. Okay. Now profit function is given, profit for the 13.5 and 55. With the help of this profit function we have to write down profit for the maximize. Okay, so here we write the profit 35.5 for the bulbs, but bulbs we consider as X, that's why 13.5 X and Y unit of a tube. Okay, but we have a 55 rupees of a package of one tube, so number of Y tube, we got the profit 55 into Y, where X and Y are unit of package of bulbs and tubes respectively. Therefore X is greater than equal to 0 and Y is greater than equal to 0 restriction. Now the remaining part is a constraint. Okay, so constraint we write from the given condition. The given conditions are, these are the given conditions from the machine 1, 1 into bulbs X and 2 into tube Y, and availability is 10. So maximum availability is given 10. So 1 into X plus 2Y less than or equal to 10 on machine M1, 3 into X plus 4 into Y less than or equal to 12 on machine M2. Okay. Formulate LPP is as follows. First, maximize Z 13.5x plus 55y subject to x plus 2y less than or equal to 10, 3x plus 4y less than or equal to 12, and the constraint is x is greater than or equal to 0, y is greater than or equal to 0. Now the other questions are similar and you have to solve your own. Okay, try to solve your own sum and take the help of this video. You can solve the other sum easily. Thank you.